morning friends, and in this video we are going to discuss about the integration. This is our second video about integration. In the previous video you learned about how to find the integrations of some basic functions which have been differentiable. Now we also learned that the differentiations and the integrations are just reverse process of one another, and then the function which is differentiable and gives you another function after differentiation, if that function is integrated you can get the previous function back. What does it mean? It means that if differentiation of fx is f dash x, then integration of f dash x dx is fx plus c. It means that the function fx, when it was differentiated with respect to x, you got another function that is f dash x represented as, and if f dash x is integrated again, dx means integration of f dash x with respect to x, then you get your function back along with some constant, that is c, that's called as constant of integration. Now using those concepts we derived or we discussed about some of the formulas of differentiation, and then how you can get some formulas for integration. For example, I'm just taking one example again, that if differentiation of e to the power x is e to the power x, then integration of this e to the power x dx is is e to the power x plus c. Now we have discussed the formulas, some basic 10-11 formulas of differentiation and integration together, which you can watch in our previous video. Now we also discussed some of the basic method of substitution, and now here we are continuing from that method of substitution. So just let me clear the screen. So see, here we have a theorem. This you can call it as theorem or a mathematical statement which says that if integration of fx dx is gx plus c, means if integration of a function fx is gx plus c, then integration of a function of the form ax plus b dx will be 1 upon a g ax plus b plus c. Now we have to find the proof of this theorem, so we'll write proof. How will you prove? So we start from here only. So I write integration of f ax plus b dx. So here you say let ax plus b equals t. So I have assumed that this ax plus b is equal to t. Now I differentiate this expression or equation with respect to x. So here you can write directly differentiating both sides with respect to x. Then you find d by dx of ax plus b is dt by dx. Now a is a constant, so constant is taken out and differentiation of x is 1, so this is a, plus differentiation of b is 0, so you get a equal to dt by dx. Then you write a dx equals dt. So what I suggest you, that instead of going through this rigors, you can also assume that when you have assumed that ax plus b equal to t, then you find differentiation with respect to whatever it was. Means here this is x, so you just differentiate it with respect to and attach the word dx. So it becomes like a, differentiation of x is 1, so this is dx, plus differentiation of b, which is a constant, with respect to any variable it will always be 0, and this is differentiation of, this is t, because if ax plus b, and x is variable, so a times a variable plus constant will be a variable, so t is also a variable, so you differentiate t with respect to itself, that is dt. So differentiation of t is 1, and then you just attach dt, so you can directly get ADX equal to ADT. I find this method is sophisticated, but this actually has been derived out of this only. So when you do that, and now our function, which is the function of ax plus b, will now become the function of t. So what you get, this is ft. Then the order, which is dx, because when the ax plus b is asked to differentiate with respect to x, it makes sense. But when ax plus b has become t, it should change the order of differentiation, or with respect to what differentiation integration is happening, then this order should also change. So from dx it should change to dt. And now what is the relation between these two orders is adx, and adx is dt. So what is dx is dt over a. So you can write 1 over a dt. Now check it out again. Here adx is d, so dx equal to 1 over a dt. Now 1 over a is constant, so 1 over a outside, this is ft dt. Now if integration of fx dx equal to gx plus c, so integration of ft dt will be gt plus c, and then you attach 1 by a, so 1 by a. Now bring the whole variable substitution back. So at the place of t you write ax plus b. So this is g ax plus b plus c. Now we have proved this. Now I need to clear the screen, and then I'll take some of the formulas and then I'll try to solve them directly. So now I'm trying to connect these two values what we have discussed, like integration of sin x dx is minus cos x plus c. Then integration of sin 3x plus 5 dx is minus cos, the very same thing, 3x plus 5, and then you divide this, or write 1 by, or you can say divide by the differentiation of this. The differentiation of 3x plus 5 is 3, so this is 1 by 3 and then plus c. This differentiation you can write 1 upon this, but keep this in your head, it is possible only when this is a constant, because if you get a variable then this is not going to work. Now same way, if I have e to the power 5x, this is the basic formula, e to the power x dx, integration of e to the power x dx is e to the power x plus c. Now integration of e to the power 2x plus 3 dx equal to e to the power 2x plus 3, as it is, whatever it is, the same thing is here, into 1 upon differentiation of this, that is 2 plus c. Now if I say that sec square x, integration of sec square x is tan x plus c. So if you have integration of sec square ax plus c dx, then this will become tan ax plus c, and then 1 upon differentiation of this ax plus c, which is a, because differentiation a is constant, differentiation of x is 1, and differentiation of constant c is 0, plus c. So this is how these formulas will be derived. Now I take another form. Now you know that integration of 1 upon x dx equals log mod x plus c, and then integration of 1 over, I write this time a little different, 3 minus 7x dx is log mod 3 minus 7x plus c, and then 1 upon differentiation of this, which is minus 7. So this is how these kind of differentiation, this kind of integrations you can derive just by substitution. But keep all this in your head, that this is just a method of substitution, we are just trying to do it directly. So one final time I will just try to show that how this is a method of substitution. Suppose I have a question that integration of 7 sec 7x minus 3 tan 7x minus 3 dx. We can write directly integration of sec x tan x is sec x. So integration of this will be sec 7x minus 3 plus c, and then here you write 1 upon the differentiation of this 7x minus 3, which is 7. Now how? Because this here I have written directly. Now the whole idea goes like, we are taking 7x minus 3 as t. This is method of substitution. So if you just find differentiation, find 7 dx equal to dt. This becomes sec t tan t, and the dx is 1 over 7 dt. So 1 over 7 is constant, comes outside, and this is sec t tan t dt. Now this is 1 upon 7 sec t plus c. Now put the value of 7 back into the expression. So 7x minus 3 plus c. This is what it is. Okay, so this is how we have got all these formulas. Now I'll go into the second form and I'll take another form of integration. Okay, this form is called the sum of integration is the integration of the sum. So integration of two function fx plus gx. So integration of sum equals sum of the integrations, that is fx dx plus gx dx. Means when you are asked to find the integrations of a functions which is the sum of two or more functions, then you have to find their respective integrations and just simply add. So I have taken one example. Now let me find one example. Suppose if I write sin x plus x square plus tan x dx, like this. Then what you have to do? You have to make it sin x dx plus x square dx plus integration of tan x dx. Now integration of sin x is minus cos x plus integration of x square is of the order x to the power n. So this is x to the power will be added, because integration of x to the power n is x to the power, integration of x to the power n dx is x to the power n plus 1 over n plus 1 plus c. So integration of x square dx is 2 plus 1 over 2 plus 1 should become x cube over 3, plus integration of tan x is log sec x plus c. So this is how you can find these kind of situation. Now I'll take one more example. So for that I need to clear the screen. Suppose we have a question of the form x cube plus 5x plus 7 upon x root x dx. Then how you can find it? Can this be broken down into the form of this? The answer is yes. How? So this is x to the power 3 over x root x dx plus 5x over x root x dx plus 7 over x root x dx. Now x root x is, what is x root x? So x root x is x root x is x into x to the power half. Now use indices. This is 1 plus half, that is 3 by 2. So the whole thing becomes like this. So this is x cube over x to the power 3 by 2 dx, plus this 5 is constant, so I take it outside, and then again we have x upon x to the power 3 by 2 dx, plus 7 is again constant, and then write 1 upon x to the power 3 by 2 dx. Now this is in the form of a to the power m over a to the power n. Those who have studied indices, they know that a to the power m over a to the power n is a to the power m minus n. So 3 minus 3 by 2. 3 minus 3 by 2 is 2, 3, 6 minus 3 by 2 is just 3 by 2. Same way here it is 1 minus 3 by 2. So 1 minus 3 by 2 is 2 1 are 2 minus 3, that is minus 1 by 2. And this is one more formula goes like a to the power m minus m is 1 upon a to the power m, or a to the power 1 upon a to the power minus m is a to the power m. These are the formulas of the indices. So here the form is still we haven't applied the rule of integration, we are just manipulating it algebraically so that it can come into the respective forms where we can use the formulas of integration. So this one is now x to the power 3 by 2, x to the power 3 by 2 dx plus 5. This one is x to the power minus half dx plus 7. This one is x to the power minus 3 by 2 dx. So in all these cases the only one formula which we can find is applicable is that integration of, let me write here with the red pen so that you can conclude it easily. So this is x to the power n dx is x to the power n plus 1 over n plus 1 plus c. So now I'll be doing this one directly because I'm running out of spaces here. So x to the power 3 by 2 plus 1 is 5 by 2. So it will become x to the power 3 by 2 plus 1. So I can write directly 5 by 2 over 5 by 2, which I can reciprocal, this become 2 by 5 plus 5 times x to the power minus half plus 1 is x to the power half upon half. So I write reciprocal of 2 by 1 plus x to the power minus 3 by 2 plus 1 is minus 1 by 2. So this is x to the power minus 1 by 2 upon minus half. So I make this one as minus 2. So this is our answer. This 5 by 2 will become 10. So your answer is 2 by 5 x to the power 5 by 2 plus 10 x to the power half minus 2x to the power minus half. And all together we have one simple constant of integrations. However, since there are three integrations, so you will have the three constant of integrations. You can call them as C1, C2, C3 if they have any. So C1, C2, C3, just add them all and then get only one constant, that is called as C. So you can conclude that this constant of integration C is the sum of C1, C2 and C3. So C can be written as C1 plus C2 plus C3. But in the school level understanding, no one cares about whether you have written C1, C2 or not. You just write one constant of integration for all, and that actually is the sum of constant of integration for all the three. So this is how simple integrations are achieved. In the very next video we'll take some more beautiful forms and then again we'll try to get their integrations. But again I'm just telling you one thing very frankly, that integration is all about getting the form and then applying the formula. If you get the form correctly, then you can always integrate it in a very easier way. Thank you very much. Have a very nice time.